Hi to everyone. This is K. Srinivas Rao, working as Assistant Professor in the Department of Information Technology, Vignans University, Vadlamudi. This series of lectures, I am going to deal the subject Internet of Things, which is in the short form IoT. Before going to explain the subject, there is a 2 minutes video which gives an overview about the subject. Thank you.
We have all heard of the term Internet of Things or IoT. As it is becoming an increasingly growing topic of conversation, let's try and understand what exactly is Internet of Things. You may be watching this video on your PC or phone and it is connected to the Internet. Internet on your device could be connected through broadband or Wi-Fi. Simply put, this is the concept of basically connecting any device with an on-off switch to the Internet. There is people-to-people connection, there is people-to-machine connection, and then we have machine-to-machine connection. Internet of Things or IoT refers to billions of physical devices around the world that are now connected to the Internet, collecting and sharing data. As the price of processors and wireless networks go down, technology is becoming cheap and penetration of smartphones are skyrocketing. It has become possible to turn anything into a part of the Internet of Things. It is like adding a level of digital intelligence to the devices that would allow them to communicate with a human being or with another machine. And that's not all. According to reports, there would be more than 26 billion connected devices by 2020. That's a lot of connections, isn't it? But why on earth do we need so many connected devices? Let's take another example. Mike has to go for a morning meeting. His alarm clock wakes him up at 7 a.m. and notifies the coffee maker to start brewing coffee. When he goes to take a shower, the geyser was already notified and warm water was available for Mike, saving his time. Mike's car is connected to his calendar and tells him to take the best route to avoid traffic. If the traffic is heavy, his car might send a text to another party notifying them that Mike will be late. The Internet of Things can be applied to transportation, production, smart cities, and many other projects, saving us energy, time, and reducing waste. We are yet to completely understand how Internet of Things will impact our lives. What would be the opportunities and challenges that will come with it? For now, the best thing that we can do is to educate ourselves about Internet of Things, because IoT storm is here to stay, and the new rule of the future is going to be anything that can be connected will be connected.
After watching the video, you have an idea about the IoT. In this particular session, I am going to deal with the subject as follows. This is my agenda for this session. First point is need for IoT. Second point is what is meant by IoT. And third point is applications of IoT. And last one, future scope. This is the agenda of today's session. We will see one by one. What is the need of IoT? You just imagine without IoT we can't do anything. Yes, we can do anything before IoT and after IoT. There is a drastic change of invention of IoT, reducing human intervention in an machine cycle. IoT is the combination of three key terms: globally connected network and connecting devices and some sensor networks. These three can be known as Internet of Things. Among these three, there are various devices can be collectively connected through the Internet. Next, have a look about the what is meant by Internet of Things. Internet of Things is a platform which is regular devices are connected to the Internet. So they can interact, collaborate and exchange the data with each other. The exchange of data can be done through the internet. Sometimes the internet may be called as cloud computing platform. Just imagine we have various number of home appliances. Those home appliances can be connected through IoT connectivity like air conditioner, washing machine and some electrical and electronic gadgets. For example, you forgot to turn off the AC while you are coming out from your home. You can easily operate from your office. That particular AC can be turned off in that particular area. You just not only this, there are number of applications can be developed by using IoT. Once again, I am stressing the definition. Internet of Things is a platform which regular devices are connected to the internet. Now, we will see about the various applications of IoT by one. There are numerous applications are there. First, IoT in everyday life, not only home appliances and more application in healthcare, smart cities, agriculture and industrial automation, and finally in disaster management. Now, have a look about how IoT is used in our everyday life. There are numerous examples. I already explained some example regarding air conditioned unit at our home. You just imagine you brought a new AC, the particular AC having the IoT capability like temperature reducer based on the room temperature, and you may go out from your AC. You also control that particular AC through IoT devices. You can minimize the AC, I mean to say, which conforms to reduce the temperature or outside environment, like based on the clouds. We can easily monitor the one by one temperature of the AC connectivity. Thanks for IoT. And not only this kind of everyday life, you can go everywhere throughout the anything. So, which means internet is inherited in our life. Like that, Internet of Things is also same thing, which can be used in the data analytics and personal computers. Now, have a look into the IoT in the healthcare. Healthcare is very crucial even nowadays in COVID days. Previously, without IoT, the real-time data is not available at the end of the doctors, hospitals records. These are the three factors of the healthcare industry. First one, there is no real-time data available, lack of smart care devices are not available, and inaccurate standard of analytics. These all three things you can be overcome by using IoT. Have a look. By using IoT provided and real-time data, and IoT makes devices too smarter, as well as IoT provides far away the superior analytics. I have to mention an best example for this particular healthcare system. What are the various solutions provided by IoT? Let us imagine working a smart care device. Care devices can monitor, and based on that data can be given to the smart sensors, and connectivity gateway is given to the next level, which is the cloud. Cloud is sometimes called the internet connectivity around the various smart devices analysis. And later some remote signal. Here remote signal is nothing but the transmission from the cloud to the particular sensor station. And at the end, smart devices is the displaying of the particular values. Once again, I am repeating the hierarchical position of healthcare system working with smart care device. First one, care devices. Second one, smart sensors. Third one, connecting gateway. fourth one cloud mechanism, and fifth one remote signal, and last very important thing smart device. And not only this, there are numerous examples can be used in the smart healthcare. Whenever the term used smart is very useful in not only healthcare system. This can be properly structured in so many applications. And one more example is based on the healthcare records. And now we have to look into the IoT, how it is used in the smart cities. As per the Government of India, at the end of 2022, there is some target fixing the IoT smart cities, which is the various controlling capabilities: waste control management, traffic management, water resource management, and housing issues, and reducing the pollution. These all 5 to 6 categories can be problems faced by the various metropolitan cities. Have a look. Let's take a smart device such as a traffic camera. Once again, I am repeating, this is the example for the smart cities, something like that, smart devices which is used in the various metropolitan cities. For example, take Hyderabad traffic signal system. Traffic camera captures the particular user's, whenever the user maybe jumps the signal, automatically the camera captures the vehicle number, and that will be directly given to the city wind monitoring system. City winding monitoring system is nothing but the whole capturing images based on the various locations of the city. That is directly given to the cloud system. Now have a look. There are 3 types of various locations like city A, city B, and city C. Even though you can easily track the vehicle inappropriate behavior in the roads by taking snapshot, by taking camera capturing, that camera capturing directly given to the particular traffic signal management system. And there are number of examples for the smart traffic system. Based on the various highway roads, there is a huge crowd of the school children. They are going to the, just crossing the road from one side to another side. This is example for one of the traffic management system. Now we have to look into the IoT in agriculture system. How IoT is used in the agriculture system? There are 3 major drawbacks before using IoT. Those 3 drawbacks can be overcome. First one is precision farming, and second one is smart irrigation, and third one is smart greenhouse. I will explain one by one by using some example. What is meant by precision farming? Precision farming is nothing but based on the soil moisture and soil, based on the content, soil erosion, like that. We can build different types of sensor at each level. Okay, what is the use of IoT in greenhouse? What is meant by greenhouse? Greenhouse is implicitly used for the plantation as well as the greenery about the particular area or some location. And not only this, based on the various sensors and actuators, this can be easily controlled and switched together from 1 to 2nd position. For example, you just take an example based on the connection gateway, and the cloud information can be easily exchanged with the remote commands. There are, in this particular diagram at the below, there are various types of greenhouse mechanisms, something like electrical bulb, some motor, some AC, huge amount of fan, and some electrical AC. You can easily operate whether the usage of electricity and usage of motor, whatever it may be. You can easily turn on and turn off based on the various sensor units. The output of the sensor unit capability can be done by using the monitor or some display system. Wherever you go to the any location, smartphone used as a perfect IoT device. And one more example, IoT in industrial automation. Before going to explain industrial automation, I am giving an example. Nowadays, there is a huge platform for e-commerce. India is the hotspot. You just imagine, what are the problems faced due to the manual practice in the industries? First problem, solutions for the problems: optimization, quality control, cost effective, and security. These are the 4 solutions for the industrial automation. Before going to explain in detail about the industrial automation, I want to share one example. One particular person is related to the quality control. That particular person's job is quality, just checking the quality. And one more person is completely at the end of the cost efficient, which may be the labor, how the labor are working and how the labor working hours done, like that. Now we have a look into the IoT in the disaster management. Disaster management is not only for the weather forecasting. There are various applications in the disaster management. What are the problems faced in developing countries? High population density, poor evacuation infrastructure, exposure to the severe weather conditions. Here, the third point is very, very important, like our developed versus developing countries. Exposure to the severe weather conditions. Have a look on the India geographical structure. From Kashmir to Kanyakumari, there is various drastic geographical positions. What are the solutions by using the IoT? First one, preparedness. Second one, correctness and solution given to the particular problem. Now, use of the IoT in the forest fire. Forest fire may be occur in temperature and carbon emission sensors. Based on the sensing element of the emission sensors, you can easily identify where is the exact location forest firing is occurring. The particular alert may be displayed on the coordinating on some smartphone device. Alerts will be displayed in the control room. This is something like hierarchical notation. Whenever the sensor predicts. And what is the future scope of the IoT? The future scope of the IoT is very, very huge. You can just imagine how IoT is used in our day-to-day life, as well as what is the future scope of IoT. Future scope of IoT is based on the various factors, based on the millions and billions of devices using in this smarter way. In energy sector, energy efficient algorithms need to be designed for the system to be active too much longer. Not only this particular energy sector, there are various sectors. And there is one more challenge regarding with security. We need to information circulation methods to secure the data as well as the privacy of the user. And last one is very, very important. First one, second one is somehow easy to manage, but real-time data is very, very important. We need to reduce the gap between the machine real-time data as well as the actual real-time data, which is nothing but the static time and dynamic time. You can easily overcome the static time by using various sensing capabilities. Now we will discuss about the history of IoT as well as the evaluation of internet. Since 1830s to till date, that is 2020, there is a drastic change of internet as well as Internet of Things. In the year 1830s, I mean early 1830s, the invention of the telegraph is the first invention regarding the IoT device. Later, second half of 19th century, the first machine-to-machine applications evaluation done. Later, in the year 1920s, Nikola Tesla company predicts a smart device, and later in the year 1980, vending machine as the first smart device ever, which is sometimes called ATM. In the year 1990, John Romke makes the first toast maker via internet. The father of Internet of Things is Kevin Austin, who proposed the World Web WWW, World Wide Web, which is connected to the IoT devices. And the year 2008, the number of IoT devices exceeds the total world population. There is an estimation by the year 2020, the IoT connection or connected devices, those may be reach the 30 billion. This is an estimation. Even in the year 2019, December month, in the year 2019, December month, they predict the estimation of IoT connected devices that may be reaches 50 billion. And we will discuss about the various things based on Internet of Things devices and what are the connecting smart devices. Later, we will discuss about second point. What is the exact definition of Internet of Things? Internet of Things is the combination of three terms. First term is dynamic global interconnection, and second one is self-confirming capabilities, and third one is the various smart devices. These three terms is very crucial for IoT definition. This is the exact definition for the IoT. Dynamic global internetworking with self-confirming capabilities of devices. That devices may be mechanical or digital machines or sometimes objects or physical attributes. Once again, I am stressing the exact meaning of devices. The device may be smart device, the device may be electrical equipment, the device may be some mechanical capability. Just imagine electric motor. The best example for the electronic gadget is smartphone, smart watches, something like that. And we will differentiate between the what is meant by internet and what is meant by Internet of Things. Okay. What is meant by internet? The internet is the term given to the network that is formed by the connecting computers across the globe, that is globally. And have a look about the Internet of Things. When you expand the capability of internet from connecting computers globally to connecting several small electronic devices. In this particular definition, he mentions only electronic devices. Even though the smart device is not only electronic devices, that may be anything. Just have a look about the internet and Internet of Things. Internet is given by the network. This is formed by the connecting computers throughout the world, that is globally. And right side of the definition is the IoT. The definition is restricted to the electronic devices only. Later, we will discuss about the various factors of IoT, and this is the best example for a simple definition of IoT. In this particular diagram, there are various devices are there like computer, camera, some electronic plug, and some actuators like thermometer, some home appliances like washing machine, air conditioner, smart lights. In this particular diagram is the perfect example for the smart devices as well as the smart gadgets. And this particular diagram mentions the number of connected IoT devices versus evaluation of years. from the year 2012 to till date, that is 2020. The graph is drastically changes from the exponentially. Just have a look. For example, take 2015 as example. You just compare 2015 with 2014 and 2016. In the year 2014, 14.14 billion devices connected, and in the year 2016 that will automatically exponential by 22.9 billion devices. This is the just rough estimation of connecting devices throughout the world. And now this is new topic to our course. This is the very important as per our curriculum. What is meant by data, information and knowledge? You just imagine our university. Our university consisting of n number of departments, and each and every department having some set of students. I want to retrieve one particular student details. How? Yes, based on his registration number. For example, the difference between data and information. The data is raw content, unprocessed, obtained from the end devices. Data may be sometimes unprocessed. We need to process that particular data into processed one. Whenever data is processed to unprocessed state to processed one, which is called information. In this example, data can be filtered and processed. We can categorize it by based on one primary key, that is registration number, and we can be consolidated the all registration numbers, that is called some set of department. Let us assume our department information technology. A student newly joined in year 2020. First two digits indicates the 20, stands for year of admission, followed by 1AO. 1AO is nothing but the course name. Let us assume IT department having the code 1A, 1FA like that, followed by some registration number. The whole thing can be converted and categorized. Categorized data can be called as information. Okay, what is the inference from knowledge, from data and information? It is very important. The knowledge is nothing but the pinnacle point of the information. What is meant by pinnacle point, I will explain in the later slides. Here, information can be organized and structured and can be acted upon the achieve some specific object. One more example I want to share with you. I want a particular student having registration number 19FAO like that. Based on that particular registration number, I need only that particular student semester end result. Yes, it is possible. That is possible based on the database, retrieving of the information from the database. And we will see about this particular DIKW pyramid. See here, from top to bottom, here there are 4 slides from the top to bottom. The top name is called as knowledge and the bottom level is called data. Now I want to explain about this particular pyramid with an appropriate examples. 192.234. Something like that, which does not use any information. Information which gives some meaningful form. Thus, meaningful form it may be given any manner. And third level is called knowledge. What is meant by knowledge? Knowledge is nothing but the context. which context you are saying this particular values comes under IP address. Which context you are saying this particular roll numbers are registration numbers. Which context you are saying that this all following comes under the fruit names, like that. And the pinnacle element is called as the wisdom. Wisdom is the applied mechanism of knowledge data discovery. Sometimes that is called KDD. Knowledge discovery data. Yes, this is the overview about the pyramid DIKW. You need to start from bottom to up. Bottom is always raw data and topmost one is always some wisdom. And we will see about the particular knowledge discovery process. In this particular slide, a person is thinking about how the data is going to be converted into data to, raw data to knowledge level. Okay. Each and every stage there is some input as well as the output of that particular stage can be directly given to the next step. Here, data warehouse. Many times we heard the word data warehouse. What is meant by data warehouse? Data warehouse is nothing but raw data can be directly given to the bunch of information. That is sometimes called data warehouse. We need to collect which kind of data we want. That is the second level, which means selecting and cleaning. The input of the first stage is raw data and the output of first data is the raw data unprocessed one that can be given to the input of second one. Second stage. Second stage is targeted data. What is meant by targeted data? Targeted data is very specifically taken from the selection and cleaning process. After that particular stage, we will directly give it to the next level. That is called transformed data. On the transformed data, we can apply various number of data mining techniques. You already learned this particular topic in your previous semesters. Based on the patterns and rules, we need to maintain some set of rules as well as some patterns. Let us imagine we will just have a look about I want to retrieve fruits names as well as vegetable names. Let us assume I don't want to give any information. First comes under the fruit category. The fruit may be not only specifically in the shape of round. Some fruits may be comes under the something like horizontal or vertical, like that. Just come to the vegetable category. You need not worry about the size and shape of the fruits as well as vegetables. Yes, we want to maintain some pattern. Yes, this is the size of some mango and this is size of some tomato. I am talking about size. I am not talking about the color. I am giving only one parameter, of course, which is pattern. That may be comes under only size. Okay, I want to give one more attribute. I want to include one more attribute, color. First one is size, second one is color. Based on that particular pattern, we can easily categorize. Yes, this all are comes under the fruits. This all are comes under the vegetables, like that. You just go through the last stage, that is called knowledge level. This process is sometimes called knowledge discovery process. We started from the discovering of the raw data to pinnacle element, that is called knowledge discovery process. Now the man is somehow able to understand about what is meant by raw data and what is meant by knowledge level base. Here, this is the integration part of the knowledge level. The interpretation and evaluation can be done at the last stage, that is called knowledge discovery process. Sometimes it is known as in the short KDE or KDP. And we will see what are the various characteristics of IoT in the next class. Thank you. After the completion of Internet of Things applications, let us examine IoT characteristics. There are 5 characteristics of IoT. The first characteristic is dynamic and self-adapting. Second characteristic is self-confirming. Third one is interoperable communicating protocols. Fourth one is unique identity. Fifth one is integrated into information network. Based on these 5 characteristics, we will go through the one by one with an appropriate example which is used in our real life. The first characteristic of IoT. What is the first characteristic of IoT? Yes, dynamic and self-adapting. IoT devices and system may have the capability of dynamically adapted with the changing context and take action based on their operating conditions. The user's context or sensed environment. For example, just imagine, consider an surveillance system. The surveillance system can adapt their modes. For example, to the normal mode to infrared, like in the night mode, based on the whether it's day or night. Whenever any person residing in the room, in that room, based on that light condition, the camera functioning automatically varies. The same camera can be used outside of the room, that will automatically adapt it, which means self-adapting. Cameras should switch from lower resolution to higher resolution modes based on the various pixels elements. When any motion is detected and altered nearby the cameras, do the same thing. In this particular example, the surveillance system is adapting itself based on the context and changing the environment. The changing environment is sometimes dynamic conditions. And the second and foremost important characteristic of IoT is self-confirming. The name itself mentioned, IoT devices may have self-confirming capability, which allowing large number of devices to work together to provide a certain functionality, such as like weather monitoring, weather forecasting, like that. These devices have the capability of configuring themselves, which is adapted with respect to IoT infrastructure. For example, set up the networking and fetch the latest software upgrades with the minimal manual intervention. This is perfect example for self-configuring capability. And third point is interoperable communication protocols. IoT devices may support a number of interoperable communicating protocols and can communicate with each other. Not only communication, the communication between the devices as well as around the infrastructure which is already built. There are a number of common communication protocols we will discuss in later chapters. And fourth one is unique identity. Each IoT device has unique identity and a unique identifier like IP address or some URL or some uniform resource locator. IoT systems may have intelligent interfaces which adapt based on the context and allowing to communicate with users and the environment context. IoT device interfaces allows users to query the devices, the monitoring the status and the controlling capability may be remotely. also. And this is the complete management infrastructure. And foremost and last point is integrated into the information network. IoT devices are usually integrated into the information network that allows to communicate and exchange data other devices and systems. IoT devices can be dynamically discovered in the network by the other devices or other network, and the capability of describing themselves based on their characteristics to other devices or some other user applications. Just consider one example, particular integrated into information network. A weather monitoring node can describe its monitoring capabilities to other connected node so that they can communicate and exchange data. Integration into information network helps in making IoT system as too smarter due to the collective intelligence of individual devices in collaboration with the infrastructure. Thus, the data from large number of connected weather monitoring IoT nodes can be aggregated and analyzed to predict the weather. Whether today is shiny day, it may be tomorrow or day after tomorrow, it may be some rainy season, it may come like that. These 5 are the characteristics of IoT. Later we will discuss about the what are the endpoints of IoT. What characterizes IoT is the endpoints. Just imagine what is meant by endpoints. The endpoints are nothing but the things. Here in this particular slide, there are 3 sections as well as the combination of 3 sections into one thing, that is called Internet of Things. What is meant by physical object? Physical object is nothing but any device. The device may be electronic gadgets or some electrical machinery or something related to automobile industries. And second part is controller, sensor, actuator. These 3 terms can be used in independently. Sensor is nothing but the sensing capability having. And third one is internet. The 3 things can be combined into IoT. And we will discuss about the next slide based on the IoT characterization. And this slide belongs to the IoT end-to-end architecture. End-to-end architecture is nothing but the from starting to end. Here the starting is device and end is the some display, something like monitor. See here, the first part is sensors or actuators. The term sensor or actuators may be any thermostats, any sensing capability instrument, like whenever any person suffering from fever, he automatically use the thermometer. It may be electronic or some physical thermometer, like that is having some sensing capabilities. And second part is device. The device may be any printed circuit board or any Raspberry Pi, like that, which is something like electronic devices. And third one is gateway. Gateway is nothing but internet by using some modem or some routers. And fourth one is the storage capability, that is called cloud computing mechanism. The 4 stages can be known as IoT end-to-end architecture. And we will discuss about in the later slide what are the various IoT end devices. These 3 factors, first one is intelligence, second one is sensing and actuating capability, and third one is communicating capability. What is meant by intelligence? Intelligence is nothing but the whenever you are doing any operation, based on that operation, some data can be collected. Based on that data, you can easily sense, yes, this is the set of IP addresses, this is set of some vegetable names, this is some set of fruits names, like that. We can easily categorize. Sensing is not to the something like touch or seeing or tasting the things. And third one is communication capability. Communication capability is nothing but the gateway, something like you may use any router or modem, that can be communication capability. This is the end of today's session, and this is the assessment test for session 1. Even though session 1 is too lengthy, you need to understand what is meant by IoT. Second one, need of IoT. And third one, definition of IoT. Fourth one, you give any 3 applications of IoT. And last one, characteristics of IoT. We already discussed about the 5 characteristics of IoT. Next session, we will discuss about 2 different topics, physical IoT as well as logical IoT. Thank you. Thanks for watching my videos.